the future's calling. Maths and mind colliding. Daily dose of power. AI's here. Siyaya. Kubeka, let's learn the new way. Siyahamba phezulu. Daily dose of power. AI's here. Siyaya. Kubeka, let's learn the new way. Siyahamba phezulu.
Hi guys, welcome to the Daily Dose of Mathematics. So this is the question that most learners were complaining about. We are busy with the Limpopo June 2026 question paper. This was the most challenging questions of the number patterns. Itu, what are we doing today?
So now this question is 3.2.4, by which we are determining the number of times the ball will rise to a height of more than 4 meters, which is 6 marks.
Okay, let's just understand something. We're looking for the number of times.
Okay.
They say we're looking for the number of times in which the ball will rise. Keyword, guys. Let's highlight that Itu. So they are saying the ball will rise. Yeah?
Ball will rise.
Yeah, because we have a situation whereby our ball is rising and then it's also falling. So one thing that is for sure, guys, in this question, the number of terms we're looking for n. So let's just say n is question mark. We don't know what is n.
Okay.
And then while we are busy reading the question, we're also going to check what is it that they're saying. They're saying it's going to rise to a height. Ne?
Okay.
Now, a height of what? Of more than 4 meters.
More than 4 meters.
So it means, in other words, height is our Tn. How do we know that? We can go into that diagram and demonstrate exactly how do we know that height is the Tn. So we have the bounds and then we have the height. Ne?
Okay.
So if you look at the diagram that we have here, we have the drop. Let's not confuse the drop. So we're going to do away with the drop. Just highlight the drop. So it is dropped from a height of 30 meters. Can you see that?
Yeah.
So if we drop, they're not talking about drop here. They're talking about rising.
Yeah.
So when the ball rises, it needs to bounce first. It needs to go down, and then that's when it's going to start to rise. So if you look at the second part here, it's going to rise to a certain height. That's the first height. The height that we have first is 24. Can you see that?
Yes, 24 meters.
So after the first rise, the ball is going to reach a height of 24. So we have h, our height, as what? As 24. Yeah? And then after the second bounce, it reaches another height. Yeah? What is the second height that we see there?
The second height is 19.2.
19.2. So basically here they're saying, when is the ball going to reach a height of 4 meters? That's what we are looking for. So it says, in other words, Tn is given as 4. But remember, guys, we're going to conclude at the end to say when it's more than 4 meters. Yeah? But for now, let's just focus and say, we're looking for when is the height going to be 4. Yeah? So meaning that we're going to tell them Tn is going to be equaling to 4. We want to know when is the ball going to reach a height of 4 meters. Right?
Okay.
After how long, in other words, it's going to reach a height of 4 meters. So meaning we're going to look for n when the ball reaches a height of what? Of 4 meters. Now here, guys, we need to go and check which formula is going to give us the most results here. Is it going to be Sn or is it going to be Tn? Let's go and check on our information sheet here.
So here's our information sheet.
Now, if you think about it, which one do we have here? Do we have Tn or we have Sn? 4 meters. What is Sn? What is 4 meters?
4 meters is Tn.
Is Tn. So we're going to use the Tn formula. No? So what kind of a pattern are we dealing with? Are we dealing with an arithmetic or we're dealing with a geometric?
We're dealing with the geometric.
So if we're dealing with the geometric, let's choose the correct geometric Tn formula, which says Tn.
Tn
is equaling to
A R n minus 1.
N minus 1. Okay, that's the formula that we're going to be using. Now we're going to collect our data then. Now that we know which formula we're going to use, we're going to tell them that Tn is equaling to 4.
Yeah, Tn is equaling to 4.
And then A, yeah. Then now we have a problem with A. Now, the initial height, when it's dropped, it's 30, guys, remember? But here they're not talking about the initial height. They're talking about the rise. They're not talking about the drop. So 30 has to do with something that is dropping. Now, what is the first rise that we have? That's the question that we need to ask. What is the first rise that we have? Looking at your diagram, what is the first rise that we reach?
So then our first rise is 24 meters.
So it's 24. So it means our A is going to be 24.
Okay, that means it's going to be 24.
Yeah, and then we have our R. Our R hasn't changed. It's still exactly the same way because we are losing a height of 20 meters every time when the ball bounces. It means that it's going to retain 80%, which means it's going to be 4 all over 5.
That means our R is going to be 4 all over 5.
Yeah, 4 all over 5. Okay, now let's go and substitute them. We're going to tell them that 4, again,
yeah,
is equaling to A, it's 24.
4 is equal to A, which is 24. Open
Then open
bracket,
bracket, we have
4
4
all
all
over
over
5,
5 to the power of n minus 1. Yeah?
n minus 1.
Now, we want to make n the subject here. No? There are
Yes.
certain things that we need to do before we can make n the subject. First thing that we can do is to divide both sides by 24.
Divide both sides by 24.
So if you divide by 24 and then you divide by 24,
By which 4 divided by 24 is...
so you can say 4 into 4 goes 1 times, no?
Yeah.
And then 4 into 24 goes 8 times. Let's just check. It's 4, 8, 12, 16,
That means
20, 24, no, it's 6. It's 4.
that means you're gonna have 1 all over 6.
Yeah, I'm going to have 1 over 6. So 4 into 4 goes 1 times, and then we can just guys, don't try to be a hero here. If you're not sure, just go in and press it in your calculator so that you make sure that you do the right thing. Let's go to the calculator. Let's just make sure that we are not losing unnecessary marks. And then let's also teach learners doing the right thing instead of trying to be heroes. So we have 4 divided by 24. Yeah,
It's
and then
1 over 6.
1 over 6. 1 over 6 is going to be equaling to, open bracket again.
Yeah.
It's 4 all over 5 to the power of n minus 1. Now we have a problem. You see our variable is on the exponent. No?
Yes, sir.
Now, how then do we make sure that we can take our variable down? Who is the person who has the power to remove an exponent downwards? Who has that power? It's log.
It's
No?
the log.
Yeah, so we're going to introduce our log. So we're going to tell them that so we're going to put the log. Okay?
Yeah.
If you put the log is going to steal our base here.
Yeah.
So we're going to have n minus 1. No?
Okay.
And then this thing here is going to go to a base. Then you're going to have log. Then we have 4 all over 5, close bracket.
4,
And then
5.
you have our number as 1 all over 6.
1 all over 6.
Yeah. And then we're going to go to our calculator and look for the log that has, it's that log that has a log and then it has some blocks so that we can put the 1 all over 4 all over 5 and 1 all over 6.
Here's the log.
Yeah, so you need to choose the right log. And then you open the bracket. It's already opened the bracket and close the bracket. Okay?
Yeah.
So now we just type. We are going to put 4 all over 5.
All over 5 first.
Yeah.
4 all over 5. Then
yeah.
in at the bracket, we're going to put 1 all over 6.
1 all over 6. Okay. And then we should get an answer.
1 all over 6. Which is equivalent to 8,029.
8,029.
0.296. But when we are running it into 2 decimal places, we're going to have 8,03.
8,03.
Yes, sir.
Okay, so we're going to say we have 8,03 no? Is equaling to n minus 1. Okay?
Yeah.
We're looking for n here. So we're going to take the minus 1 to the other side. Okay?
Yes.
Now just add it so that we don't have many steps. So we're going to tell them n is going to be equaling to, if we say n1 is negative, when it jumps the equal sign, it becomes positive.
Positive.
So we're going to have 8,03 plus 1 is going to give us 9,03.
Which our n is equivalent to 9,03.
Yeah, now what does this mean? It means the ball is going to reach a height of 4 meters after 9,03.
Okay.
Now, if you look at this, we want it to have a height of more than.
Yeah.
So let's go to our diagram again.
Go into our diagram.
Yeah, if you go to a diagram, then you will realize to say, okay, if I move to this direction here, the ball is going to say, remember, okay, let's put it this way. Our n cannot be a decimal. Okay?
Yes.
So we have an n which is going to be equaling to 9, or the n is going to be equaling to 10.
Okay.
So let's just go to that diagram there and then go at the end and just say n is equaling to 9. Okay?
N is equivalent to 9.
Yeah, so we have more than 4 meters. More than 4 meters is this side in this direction. So we have greater than 4 meters, we have people that are this side.
Okay.
And then less than 4 meters, we have people that are, remember when we go, as we move on, the height keeps on decreasing.
Yeah.
So if I go backwards, I'm going to get people which are
greater than 9.
Yeah, greater than. Then it means, in other words, we're going to tell them which therefore our n is going to be equal to what? 9.
Okay.
I'm not sure if this part makes sense. Whereby we're saying once we have 9,03, I think we have 9,03.
Yeah.
9,03 is when the height is 4 meters.
Okay.
Now, when we go to this direction here, we're going to have something which is going to be less than 4 meters.
Less than 4 meters.
Yeah, but when we go into this direction here, if you go to that diagram, if you go to that direction, you're going to have people which are greater than 4 meters.
Greater than 4 meters.
Yeah. So basically, it means after the 9,03, we can either go to 10 or we can either go to 9. Right?
Yeah.
So where are we supposed to go? I was supposed to go to the 9 or I was supposed to go to the 10. Now, the 9 is the person who's giving us people which are greater than 4 meters. Right? Because if you check here, this thing here, if you move in this direction, it keeps on climbing and climbing again.
Yes.
But if I go in this direction, this thing it keeps on going down and going down.
Okay, yeah.
So it means the height is less than 4 meters.
Less than 4 meters.
Yeah, so on your diagram here, you can just demonstrate that to say, once we have 9,03, 9,03 is when the height is 4.
9,03 is when the height is 4.
Okay, but when we go in this direction, on the right-hand side, the height is going to be less than 4 meters.
Yeah.
So after bounce 10, it's less than 4 meters.
Yeah.
But after bounce 9, then we can clearly see it's going to be more than 4 meters. Yeah. Because 9,03, it gives us a height of 4 meters. So if we want greater than 4 meters, it means we need to go back to the left-hand side.
Yeah.
It makes sense.
Yeah, it makes sense.
Okay, let's try to check can we copy our answer and then put it on our senior marker. While we do that, we're going to play the song.
Okay, let's play
the song, yeah.
Let's play our song.
Attention in the studio, let's get the sequence straight. We are talking about the ratio, the multiplier, the R. Don't calculate the drop, calculate what remains. Asambe! They say the ball is bouncing, losing 20 E's on the way. If you multiply by 20, you are throwing marks away. Subtracted from 100, what is left is what we need. 80 is kept, that's the ratio for the lead. What do you keep? Okay, that is your R. We are more now. T2 divide by T1, we taking it far. Don't multiply the loss, no, that's a mistake. Multiply by what is left, that's the total you made. Woo! 0.8, 0.8. And if they give you terms and you need to find the rule, term 2 over term 1, that's the ultimate tool. Geometric means we multiply.
Final grade, 4 quarters. Final answer, n equals 9. CAPS marking audit. 1. Marking breakdown. Step. Working shown. Mark allocation. Justification. Substitution 4 equals 24. Frac 4, 5, caret, n1, checkmark m. Correctly substituting r equals 24, r equals frac 4, 5, and setting the general term t underscore n equals 4 to find the threshold. Simplification and log setup, frac 1, 6, equals frac 4, 5, caret, n1, checkmark m. Correct algebraic isolation of the exponential base. Logarithmic calculation 8, 03 plus 1 equals n. n equals 9, 03, checkmark CA. Consistent accuracy in converting to log form and evaluating the exponent. Logical conclusion, therefore n equals 9, checkmark A. Correctly interpreting the decimal threshold to conclude that the ball bounces 9 times above 4 meters. 2. Corrective feedback. Your arithmetic and logical deductions are completely sound. You successfully used the equality method, t underscore n equals 4, to find the exact threshold, n equals 9, 03, and correctly deduced that since the sequence is decreasing, the 9th bounce is the last one above 4 meters. However, there is a structural flaw in how you wrote your logarithm step. Log underscore 4/5, frac 1, 6, equals n1. Placing parentheses strictly around the log and its base while leaving the argument outside makes it look like you are multiplying a logarithmic operator by a fraction, rather than evaluating the log of the fraction. Socratic question. To ensure your notation mathematically represents the logarithm of 1/6 to the base of 4/5, how should you reposition your brackets around the argument? 3. Caps and formal notation compliance. Terminology. You correctly applied the geometric sequence formula T_n equals R⁻n1. Notation. Fix the logarithm notation. It must be written as log_frac 4, 5, frac 1, 6 equals n1 frac log frac 1, 6 log frac 4, 5 equals n1. While using T_n equals 4 is accepted and works perfectly if your final interpretation is solid, which yours was, the mathematically rigorous caps approach for more than is to use an inequality from the start. T_n greater than 4. This prevents any confusion when rounding at the end, as the inequality signs will naturally guide you to n less than 903, definitively pointing to n equals 9. 4. Coach's summary. What you did well. Listing your variables, O equals 24, R equals frac 4, 5, T_n equals 4, explicitly on the right side of your page is excellent. It creates a visual anchor that stops you from substituting the wrong values into the geometric formula. Area for improvement. Clean up your logarithmic notation. When dealing with fractions as both bases and arguments, always wrap the argument in brackets to clearly show what the log is operating on. Log_b, x.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts. Your comment counts, tell us what you need. Your comment counts, tell us what you need. Find us on TikTok and Facebook. The daily dose of mathematics is the handle. Hit our WhatsApp for the daily prompts. Get more info on 0664 682 9994.